Hello. In this discussion, we're talking about finding the domain and the range of trig functions. Now, this is where we kind of do it by more of an algebra thing. When we get to the pictures or the graphs of trig functions, I think it becomes a little bit more clear at that time. So if you don't get it here, don't worry. You'll kind of see this again when we start talking about the graphs of them. But hopefully this will get us kind of a kickstart into the graphing approach. Alrighty, so knowing the domain and the range of the trig functions. So if we look at the sine of theta, now here's our picture again, and again this one's going to be the unit circle. And remember that the sine of theta is the b, that's your y coordinate. Cosine of theta is a, and that's your x coordinate. So if you're in the second quadrant, look here, a will be negative because you had to go left, and b would be positive because you had to go up. So in the second quadrant already, sine of theta is going to be positive, and the cosine of theta will be the negative because it's a. And then the tangent of theta is b over a, where a does not equal 0. And so that's going to be negative as well because b is positive, a is negative. So the main three, only the sine is positive. And that's going to make the cosecant positive as well because the cosecant of theta is the reciprocal, making it 1 over b. Alrighty, let's move on. Alright, the domain of a sine function is a set of all real numbers. And the domain of the cosine function is a set of all real numbers. You're like, well, why is that true? Well, if you remember, sine of theta is the y coordinate, and in the other case, it was the b. And the cosine of theta was the x coordinate, and that was the a. And so if we go back to that previous picture, if you're saying the sine of theta is the b and cosine of theta is the a, those points are always going to be defined on a unit circle. You're never going to have something that's undefined when the sine of theta is just the b and the cosine of theta is just the a, because those numbers are always defined. So in other words, as long as they're a point on that unit circle, we're going to be good, and they're going to be defined. Alrighty. Now let's look at the next one. The domain of the tangent function is the set of all real numbers except odd multiples of pi over 2, 90 degrees. So the domain of the tangent function is a set of all real numbers except odd multiples of pi over 2. Again, let's go back to the picture again. Now if you remember, the tangent of theta is b over a, right? And a cannot be 0. So the only time the tangent is going to be undefined is when a is 0. So looking at that picture, when is the a going to be 0? It's going to be on the positive y-axis because that's 0, 1 up there. You'd be dividing 1 divided by 0. And down the negative y-axis, you'd be dividing negative 1 over 0. And those are the two locations where the tangent will be undefined. So if the theta is, if that angle, that terminal angle is straight up, it's going to be pi over 2, 90 degrees. If it's straight down, it's going to be 3 pi over 2, which is the next multiple of the odd multiples of pi over 2. So the positive y-axis is pi over 2, and the negative y-axis is negative 3 pi over 2. So those are the odd multiples of pi over 2. All right, but that's going to be where the tangent will be undefined. So it's going to be all real numbers except for those. All right. Let's look at the next one. The domain of the secant function is a set of all real numbers except the odd multiples of pi over 2 as well. Same thing. So it's the same thing for this one. Odd multiples of pi over 2. You're like, well, why is that? Well, I would venture to guess probably that's because it's going to be there's going to be an a on the bottom, and it's undefined when it's on the bottom. So let's go back again and look at secant. Secant is 1 over a. There. Look at it, 1 over a. When is a 0? Same places where tangent is going to be 0 in the bottom. So the tangent and the secant would basically have the same domain because those are the locations where a is going to be 0. Okay. Now what about the cotangent one? Well, the domain of the cotangent function is a set of all real numbers except multiples of pi, or multiples of 180 degrees. So that must mean it's undefined there because its denominator will be undefined down there. Let's go look at it again. So the cotangent, that's the right one. It's a over b. Okay, cotangent is a over b. And when is b 0? Well, it's going to be 0 on the positive x-axis and the negative x-axis. So it's multiples of 180 degrees. So it's 0, 180 degrees, 360, 540. So it's all multiples of 180. Those are the places, the positive x-axis, the negative x-axis is when the b coordinate will be 0. And since cotangent of theta is defined as a over b, when that's 0, it's going to be undefined. So that's the place. So it's all angles except for those. And which one is the only one we have left there? We have cosecant, I believe, right? I don't think we've dealt with cosecant. So cosecant of theta is 1 over b, so that can't be 0 either. So that's going to have the same, because if it's 1 over b, cosecant's domain will be the same thing as the cotangent's domain, because that's 1 over b. So it's very similar. So I believe that will be our last one here. There it is. The domain of the cosecant function is a set of all real numbers except integer multiples of pi, which is the same thing as the one for cotangent. Alrighty? So that's kind of tells you why we have to restrict certain numbers out of it. And remember what domain is. The domain is the numbers that are allowed to be put in the machine. And so in this case, the domain is the angles that are allowed to be put in these particular trig functions. It's any ones that makes it defined. So since sine and cosine have no fractions involved, it's going to be all real numbers. And so you just have to make sure when there's a fraction, you got to see where those locations are going to be 0 in the bottom and then exclude those numbers. All right? So sine of theta is negative 1 over 1, and the cosine of theta is between negative 1 to 1. This is talking about the range of them. Now remember, the sine of theta is the y-coordinate, right? Now on a unit circle, on the y-coordinates, how high can the y-coordinates go on a unit circle? Well, since the radius is 1, the highest you can go is 1, and the lowest you can go on the y-axis is negative 1. So the outputs of the sine is 1 to negative 1, or negative 1 to 1. Now cosine of theta, it's the x-coordinate. And the x-coordinate on a unit circle, the smallest it can be is negative 1, because that's the farthest number to the left. And the biggest number to the right is 1, because it's a unit circle. So that's why it's between negative 1 to 1. Now, this one's a little, you got to apply what we call the reciprocal property, basically. The cosecant of theta is less than or equal to negative 1, and the cosecant of theta is greater than or equal to positive 1. Now, this one's going to be a lot more clear when you see the graphs, when we start showing you the graphs here. But what I'm saying here is if you take the reciprocal of sine, when the numbers get close to 0 on both sides, they start going out to infinity, basically. So, for example, if the sine of theta is 1, the reciprocal cosecant of theta will be 1. But when you start, like, say, sine is 1/2, because it's between negative 1 to 1, when you say sine is theta is 1/2, then the cosecant will be 2. Since sine of theta is between negative 1 to 1, it could be 1/10. So sine of theta could be 1/10. And if it's 1/10, then the cosecant of theta would be 10, because it's the reciprocal. Notice it's getting bigger. So cosecant of theta is greater than or equal to 1, because it could be 1, it could be 2, it could be 10. It could get bigger and bigger as sine of theta gets closer to 0 from the right side. Now, if it's getting closer to 0 from the left side, like negative 1/2, sine of theta could be negative 1/2, then the cosecant of theta could be negative 2. If the sine of theta is negative 1/20th, taking the reciprocal of that, cosecant of theta could be negative 20, which is getting even smaller. So cosecant of theta is less than or equal to -1. And again, if this doesn't make sense, that's okay. This is going to make a lot more sense when we see the graphs. But this is the range of the cosecant. And since cosecant is going to have this range, so will the secant, because the cosine of theta is secant's reciprocal. So that relationship is going to apply to the same thing between secant and cosine as cosecant is to sine. So in other words, what I'm saying to you is to get the range of cosecant, I'm using the range of sine. And to get the range of secant, I am using the range of cosine. And tangent of theta is between -infinity to infinity, which basically means it can get bigger both directions. Because you got to remember, A and B, tangent is B over A, and the cotangent is A over B. So A could be really small, really big, and B could be really, really small. So when you divide it by something that's really small, it gets huge. So that relationship makes them get bigger and bigger and bigger each way. So it's all real numbers. But again, it'll make a lot more sense, I believe, when you see the graphs. And that's coming up in later sections. All right, next table is a summary of what we just talked about. Sine of theta, the domain is all real numbers. And then its range is numbers between -1 to 1 inclusive, which means including the endpoints. Cosine has the same domain and range as the sine. The tangent, it's all real numbers except multiples of pi over 2, odd multiples of pi over 2. And it's all real numbers is this range, and so on down the line. Now what I would do here is I would take this, this slide, pause it, and then write them all down. So I wouldn't say you have to memorize them, because when you start showing you the graphs, they kind of stick a lot better when we do the graphs anyway. But this is going to give us a good jump start when we hit those sections. So, all right. So make sure you pause it and write these down. And that does conclude this video. If you have any questions, you let me know. And you have a good day.